Hey there guys, welcome to your 3.6 Day 1 Notes, Pythagorean Theorem and Similarity. So we're going to go over a couple of concepts. Pythagorean Theorem mainly. Before we start Pythagorean Theorem, we have to talk about simplifying radicals. So similar to simplifying fractions, so for example, if I had the fraction, let me get my pen. Let's say I gave you the fraction 25 over 15, right? Well, I know I can simplify that because I can say, well, I can divide both of them by 5, and that becomes 5/3. So we're going to use that same idea here and say, okay, well, what numbers are multiplied within my starting number? And I want to see how far I can simplify it. So similar concepts, more or less, to simplifying fractions, slightly different. Now, the main concept I'm going to be using for simplifying radicals is the idea that I want to find the largest perfect square that is a factor of my number. Now, my perfect squares I already have pre-highlighted here in green. So perfect squares are 4, 9, 16, 25, 36, 49, 64, 81, 100. Hopefully you have at least your perfect squares memorized up to 10. If you don't, that's okay. And then here are your other ones up to 20. So 121, 144, 169, 196. And these are numbers you get for multiplying the same number by itself. So for example, 2 times 2 is how we get 4. 3 times 3 is how we get 9. 4 times 4 is 16. Now, what you really need to be careful about here is 4 is a perfect square, the one I highlighted. 2 is not a perfect square. The square root of 4, which is my perfect square, is 2, but we do not consider 2 a perfect square. Neither do we consider 3 a perfect square. 9 is a perfect square. 3 is the square root of my perfect square. So hopefully that makes sense. Now, we have a pre-filled out example here, and they're saying, hey, we need to find the largest perfect square that goes into 50. Now, there's a lot of different ways to multiply to be 50. So, for example, if I had tried 5 times 10, 5 times 10 will give me 50. But you want to look for the largest perfect square. And generally, you just want to look for a perfect square when you're multiplying. So, although 5 times 10 will give me 50, 5 is not a perfect square. It's not one of these green highlighted numbers. Neither is 10. So, instead, what we found was 25. 25 times 2 is 50, and 25 is a perfect square. And the reason we're looking for perfect squares is I can see, hey, once I get a perfect square, hey, look, right here, square root of 25 is 5. So I can simplifying radicals, simplify the square root of 25 to just be whole number 5. Square root of 25 is 5. Now, 2 is not a perfect square, so it's not 4, 9, 16, 25, so on and so forth. So it stays the same, which is okay. Generally, we just want to simplify it as much as possible. So square root of 50 now became 5 square root of 2. So we're going to try another example. So in this case, we're going to try this one, 48, square root of 48. So I want to find all factors of 48. So how can I multiply to be 48? Now you might say, I'm not very good at my factoring or my multiplication. So if you struggle with finding factors of 48, what you can do is you can use your calculator, your handy dandy calculator. Out of that, hopefully I didn't change anything. And we are going to go to, sorry about the number, 48 divided by x. Now the dividing by x is just going to make my calculator divide 48 by every single integer number, or by every number. Now the press enter, you'll see your graph kind of, but we actually don't care about the graph. What we want is to press Control T for our table, because this is going to give me my factor list of 48. So for example, 1 times 48 is 48. 2 times 24 is 48. 3 times 16 is 48. 4 times 12 is 48. And within this factor list, I'm going to look for the largest possible perfect square. 2 is not a perfect square. 24 is not a perfect square, so I'm going to ignore these. 3 is not a perfect square. 16 is a perfect square, however. 4 is also a perfect square, 12 not. So we're looking between 16 and 4. Now 16 is larger, so I'm going to use 16 because that's going to be my largest possible perfect square. Now you can say, well, can I keep looking to see if there's a larger perfect square? You can. So we can keep going down our table. 8 is 6, not perfect squares. Now, let me go actually back up here. Notice how we have 6 and 8, and then 8 and 6. If your numbers happen like this, where they kind of flip from 6 to 8 to 8 to 6, that means there's no more factors. They're going to start repeating now. So I actually don't have to look any further down here, which means that, in fact, my largest perfect square was that 16 I identified earlier. So I'm going to say 3 times 16. Now, I prefer to write the perfect square first. So although it shows it to me 3 times 16, I'm just going to write it. as 16 times 3. So I'm going to say, hey, square root of 16 times square root of 3. And I know that square root of 16 is a perfect square. It's right here. So I can simplify square root of 16 to 4. Square root of 3 is not a perfect square. It's going to stay square root of 3. So this is my simplified answer. Pretty cool, pretty neat. Now for 250, 250 is a larger number, so we're going to use our calculator to get our factor list again. So we're going to go down here. I'm going to make a new calculator page. And same thing as before, 250 divided by x. We'll always divide by x. Press enter. You don't see anything, but that's okay because we don't want the graph. Control T, we want the table to give us our factor list. So I have 1 and 250, 2 and 125. 125, you can say, okay, is 125 one of my perfect squares? So then I look up here. I have 121 and 144. So 125 actually is not one of my perfect squares. So I can keep looking. Now, if you see decimals, skip the decimals. Decimals can't be perfect squares. So these can't work. 5 and 50. I know 50 is not a perfect square, and I know 5 is not a perfect square, so you can keep looking. Or you can double check your table. 10 and 25. Ooh, I know that 25 is a perfect square. So let's use that one. 10 and 25. Now once again, I'm going to write my perfect square first, just because it's going to end up going in front of the radical. It should always go in front of the radical. So I'm going to say 25 times square root of 10, which makes sense. 25 times 10 is 250. And I know that 25 is a perfect square. That's why I chose it, because I can simplify the square root of 25 to be 5 and keep the square root of 10. Now 10 is not a perfect square, so I stop here. And my simplified version of square root of 250 is now 5 square root of 10. Pretty cool. 512, okay, we're getting larger numbers, so we can keep working through this. So we're going to say, okay, I'm going to look at a new graph. And I'm going to say, okay, 512 divided by x. Once again, I'm going to press Control T for my table. 2, 1 and 512, 2 and 256, 4 and 128. So you can say, okay, well, 128, is that a perfect square? And I look here, nope, 128 is not a perfect square. And you might say 8 and 64. Oh, I know 64 is a perfect square. So let's say you choose this one, 8 and 64. So I know that 64 is going to be my perfect square. So 8 and 64. So I'm going to say, hey, square root of 64 times square root of 8. It's a little messy, but that's okay. And I'm going to highlight this color code. Square root of 64 is a perfect square. That's why I chose it, because I know it can simplify to be 8. And square root of 8. Now be careful. I purposely looked over one of the perfect squares. So if you noticed it earlier, good catch. If you didn't notice it, that's okay. There was actually a larger perfect square than 64. So I want to show you what happens if you accidentally don't choose the largest perfect square. So let's say you choose a perfect square that's not the largest. Be careful. Always double check that you can't reduce further. So if I look at the square root of 8, I'm going to ask myself, well, how can I multiply 8? Well, I can get 1 times 8, which are not perfect squares. And I can also do 4 times 2. 4 is a perfect square. So square root of 8 still has a perfect square inside of it, which means I didn't reduce it as far as I could. Now you can go back and try to look for your larger perfect square, or we can keep working from here. So I'll keep the 8 from the beginning. And I'm going to say, hey, I know that 8 is actually square root of 4 times square root of 2, because 4 times 2 is 8. And I know that square root of 4 is a perfect square. Now square root of 4 is 2, so I'm going to keep the 8 from before. I'm going to multiply it by this, so square root of 4 is going to become 2. Square root of 2 is going to stay. 8 times 2 is 16. Square root of 2. Now, double check. 2 can no longer simplify. 2 is not a perfect square, and it has no other numbers or any other perfect squares sitting inside of it. So that's actually my answer. And in fact, you, like I said, may have noticed earlier, the largest perfect square was actually 256. So 256 is actually 16. So most students are used to or have their perfect squares memorized up to 10, so that's the ones that will stand out to them. So if you ever accidentally miss the largest perfect square, just make sure you're double checking your answers that they can't simplify any further. Like I said, like 10, you might say, well, I can do 5 and 2, but 5 and 2 are not perfect squares. So this is actually as far as this one could go. So I think you get the general idea. I'm going to do the next ones a little bit faster. So 128, we're going to go back to our graph to get our factor list, and we're going to say, okay, 128 divided by x, Control C, I'm going to find perfect square. There we go, 264. I know 64 is a perfect square. So I'm going to rewrite this as square root of 64 times square root of 2. Square root of 64 is 8. Square root of 2. 2 cannot simplify further, so that's it. And then 243. So we're going to look here, and we're going to say, okay, 243 divided by x, Control P, and I'm going to look for my perfect squares. I know 81 is a perfect square. It's 9 times 9. So we're going to use 3 and 81. And remember, I like to write the perfect squares first. So square root of 81 times square root of 3. Now I kind of skipped over the highlighting, but these are the perfect squares. That's where we're choosing them. So I know that the square root of 81, and if you don't know what's up here, is 9. So I can reduce that to 9. Square root of 3. I cannot simplify 3 any further, and it's not one of my perfect squares. So that's my simplified version. So that's how to simplify radicals. Pretty neat. Now we can actually start talking about the Pythagorean theorem. So let me see if I can get these notes to work with me here. So the hypotenuse of a triangle is opposite to the right angle. A little messy right here, opposite to the right angle, which we can see here. We have a right angle, and my hypotenuse will always be opposite or across from that right angle. It's also, which we already talked about in previous notes, your longest side. Now, sometimes you can't tell what your longest side is, especially if you're not given all three numbers, but it is your longest side, or it is always opposite to the right angle, because you can only have a hypotenuse if you have a right triangle. So it's opposite to that right angle in that right triangle. So now we talk about Pythagorean theorem. We've already talked about it briefly. A squared plus b squared equals c squared. Where, remember, I know it's a different color just so it's not confusing. So let's use P. C is your hypotenuse, which is your longest side. So remember to tell if you have a right triangle. So let's say I want to check 5, 7, and 9, right? Well, my largest side is 9. So I'm going to try, wrong button. 5 squared plus 7 squared is equal to 9 squared. And I want to see if this is true. So I'm going to go to my calculator page, and I'm going to put 5 squared plus 7 squared equals 9 squared, and it tells me false. Hopefully I use the right numbers. 579, 579. So this is a false statement. So this actually is not a right triangle. And if it had said true, then yes, it is a right triangle. So don't forget that property. So not a right triangle. So let's say I want to try, So I want to try this one right here. So let's try this one. 33 squared plus 56 squared equals 65 squared. So let's see if that's true. 33 squared plus 56 squared. Plus 56 squared equal to 33, 56, 5, 65. True! So this one is a right triangle. So this, yes, right triangle. Now you can try all of them if you want. I'm only going to use these 2 examples. So now what we're going to do is we're going to say, hey, we have Pythagorean triples. We're really not going to get into Pythagorean triples. Your Pythagorean triples, if you keep looking down in your notes, are here. And Pythagorean triples are sides of a triangle that will always make a right triangle. So for example, if you have a 3, 4, 5 triangle, it's a right triangle. If you have a triangle with sides 8, 15, 17, it's a right triangle. If you have a triangle with like 9, 247, 256, it's a right triangle. Do you have to have these memorized? No. So for that reason, I'm just going to skip over Pythagorean triples. They're there. Some people memorize them. You actually don't have to memorize them because you always check if you have a right triangle by doing a squared plus b squared equals c squared. So not really necessary. But feel free to memorize them if you want. What I do want to do is this. Actually using Pythagorean theorem. So we need to find our third side. Well, first we need to identify our hypotenuse. Because we're going to use a squared plus b squared equals c squared. A squared plus b squared equals c squared. So c is my hypotenuse, which is going to be my longest side. Or it's going to be across or opposite from the right angle. So this is my c. This is my c. This is my c. This is my c. And now AB can be interchanged. So I can say this is A, this is B, or this is A, and this is B. Doesn't really matter. The only thing that does matter is our hypotenuse. So I'm going to say 8 squared plus 8 squared is equal to c squared. And I want to solve for c. So I'm going to write 64 plus 64 equals c squared. To cancel out squaring, you square root both sides. So squares and square roots cancel out, which, notice, this looks kind of like what we did for our distance formula. You can use your calculator for this if you want. So we're going to do 64 plus 64, so the square root of 64 plus 64, which is about 11.3. Now it wants my answer in simplest radical form. So actually, don't write it as a decimal. What I'm going to do is 64 plus 64, which is 128. So this is the square root of 128 equals c. Simplest radical form means simplify my radical. So if you remember earlier, if it will load in, we actually already simplified square root of 128. We said it was 64 times 2. 64 was my perfect square. So this simplest radical form is saying, or it's telling me, hey, don't leave your answer as square root of 128. We're going to rewrite it like we simplified up here. So we're going to rewrite it as 8 square root of 2. Because we simplified it. So simplify your radical. If it's able to simplify. So now we're going to look here. And we're going to fill a squared plus b squared is c squared. Now notice this time I know what c is. What I actually don't know is a. I don't know what a is. Whereas here I didn't know what c was. So in this case, I'm going to leave a as a variable, a squared, plus I know what b is, 4 squared, and I know what c is, 6 squared. I want to get a by itself, so I can subtract 4 squared from both sides. And get a squared equals 6 squared minus 4 squared. which I can do this, 36 minus 16. 36 minus 16 is 20. A squared, you want to get rid of that square, so I'm going to square root both sides. So I have a equals square root of 20, but I need to check, is there a perfect square in here? And in fact there is. 4. 4 times 5. Now you could use your calculator to look for your perfect squares. But you may have it already memorized. So 4. So that 4 I can simplify. I know that the square root of 4 is 2. So I'm actually going to have my answer as 2 square root of 5. Because 5 is not a perfect square, so it stays. So if, let's say you can't do this step and you only get to square root of 20, that's fine. That's the ideal. So, preferably you can simplify, but if you can only get to this part, that's fine. Bear with me, I know these notes are pretty long so far. So this case, I have A, I have B, I don't know C. So I'm going to use my A squared plus B squared, so 2 squared plus 2 squared of 3 squared. I'm going to put parentheses, because there's a lot going on here, equals C squared. So first off, 2 squared is 4 plus, now, 2 squared of 3. This square gets distributed. I'm going to do 2 squared is 4, so that's going to be 4. Square root of 3 times, or square root of 3 squared is just 3. Squares and square roots cancel out. So what happened was I did 2 squared, which is 4. Since the 3 had a square root, the square root and the square cancel out, so only left 3. Now I have 4 plus 12 equals C squared. So I have 16 equals C squared. Square root both sides to get rid of that square. Now 16 is a perfect square, so C equals 4. Ooh, very cool. And then finally we have this example. So notice, I don't know A. I know C. So this time, similar as before, A squared plus 4 squared equals 4 square root of 5 squared. So A squared plus 16 equals, distribute the square, 4 squared is 16, and square root of 5 squared. You can put in your calculator, by the way, square root of 5 squared if you're not sure. So if you don't take my word that squares and square roots cancel out, you can always double check with your calculator. And then we're gonna multiply this out. 16 times 5, so we say, okay, well, 16 times 5. Yeah, there we go. It's 80. So we're gonna have A squared plus 16 equals 80. Scoot on down. We're gonna subtract 16 from both sides. A squared equals 64. Square root both sides. The squares and square roots cancel out. So A equals 8, because 64 is a perfect square. So pretty neat. Now, let's go up. Hopefully it loads in. Did it pass it? I was going to show you guys something, but not necessary, I suppose. Oh, it was below. It was below. Oh, there we go. So this is how you do it. Pretty straightforward. Now, sometimes your answers will simplify, and then sometimes your answers will become whole numbers. But do not leave your answers as decimals if it's specifically asking you in simplest radical form. Now, if it's asking you round to the nearest tenth, yes, use decimals. But if it's asking for simplest radical form, do not use decimals. We went through this, so we're going to do 2 more examples, I believe. 3 more examples, and then we're done. So let me try to go a little bit faster. So we're going to solve for x, and we need to round to the nearest tenth. So for this one, we see there's a lot of triangles going on here. So I need to figure out, okay, what triangle gives me enough information? For example, if I'm looking at this triangle here, I have the hypotenuse because it's across from the right angle, but I don't know this leg and I don't know this leg. That's a problem. So then I can say, okay, well, what about this triangle up here? Well, I know the hypotenuse, but I don't know this leg and I don't know this leg. You need to know 2 out of 3 legs to use your Pythagorean theorem. Now, if I look at this triangle down here, so if I look at this guy down here, oops, not the most perfect highlighting, but that's okay. If I look at this triangle right here, I can see that, hey, I do have 2 to 3 sides. I know 5, I know 4, I need to find my hypotenuse. So I'm going to use a squared plus b squared equals c squared. Now remember, your c is opposite from the hypotenuse, so this is your c. So we actually don't know c. So a squared plus b squared equals c squared, where I have 5 squared plus 4 squared equals, I don't know c squared. 5 squared is 25, 4 squared is 16, don't know c squared. One equals c squared. Square root both sides. Go to 41. You want to double check to see if you can simplify that. So we're going to look over here to see if there's a square within it. So you'll say 41 divided by x. Control T. Is there a perfect square inside of it? Decimal, 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 decimal. And you can see you just have decimals in here because 41 is fine. So although it looks like a large number, the square root of 41 actually doesn't simplify. And now what I'm going to do, I found, so I'm going to say, hey, c equals the square root of 41. So now what I'm going to do is I'm going to, now if you're highlighting along, that's fine. I'm going to get rid of this highlight. Because now I'm going to talk about a different triangle. Now, like I said, if you highlighted, that's fine. Don't worry about whether or not you can erase your highlight. So now, oh yeah, I know this is go to 41. So now I know that, hey, right here, I have now 2 sides of a triangle. So now I'm looking at this triangle. Let me see that. How good I can do this, right? A little better. So I'm looking at this triangle. So eight's my c value, so I know my c. So for my a squared plus b squared equals c squared, I have square root of 41 squared plus, I don't know b, or a, like I said, it really doesn't matter. But I do know c. Now squares and square roots cancel out, so square root of 41 squared is just 41 plus b squared equals 64. Subtract 41 from both sides. Oh, I'm going to run out of space. C squared equals 23. Square root both sides. Square root of 23. So now I know this is square root of 23. This is nice. Now I'm getting closer to what I want. Now you might say, well, that didn't help me anything for this third triangle. I don't have hypotenuse. I still don't know what x is, though. But notice you have a rectangle. So you have 4 right angles. So although, yes, we didn't find a second side so that we can find x, since this is square root of 23 here, this is actually also going to be square root of 23. By the way, 23 is a prime number. It can't simplify any further. So pretty neat. So this is my answer. X is the square root of 23. Now we're going down here. Okay, finally to my last part. Or second to last part. There's no problem after this. We're going to see that, hey, I have this expression here. Same thing. They want me to find the length of AC. So the length of AC is, that was not really good highlighting. Okay, so we're going to try one more time. Let's see. Better. I'll take it. So this is the length of AC. That's what we want to find. So we need to go slow and steady. Now, to start off, since this is a right angle, that means this side also is a right angle. Because they're supplementary, they're side by side, so they should equal 180. Which is telling me this is my hypotenuse right here, and this is my hypotenuse right here. Now we know that these two sides are congruent. And I know the entire thing is 8. So the entire thing is 8. That means this has to be 4, and this has to be 4. And congruent means the same value, and 4 plus 4 gives you 8. So part plus part equals whole. And I want to find what this is. Now, like I said, this is across my right angle, so that's my C. And I have two sides of my triangle, so I'm talking about this triangle right here. So a squared plus b squared equals c squared. My a is 4 squared plus, I don't know my b, which is my other leg, so I'll say plus b squared equals, I know my c, which is 9 squared. So 16 plus b squared equals 81. Oh, let's go up. And we're going to subtract 16 from both sides. So we're going to do minus 16, minus 16. And you're going to get b squared is equal to 65. And then we're going to square root both sides. Squares and square roots cancel out. And then you're finally left with b equals the square root of 65. Now you can double check if that can simplify. So you can say, hey, I can go here and do 65 divided by x. It's x. Not a perfect square, not a perfect square. And you can look through it. You'll notice there's actually no perfect squares inside of here. So though, once again, although it's a large number, just because they're large numbers doesn't mean they simplify. Now this is not my answer. So this gives me square root of 65 here. Now, I want to find this entire length right here. Now, they tell me something really important here. DE is congruent to EB. So if I know these two sides are congruent, now what I can do is figure out this one. Oh, you do know this one. You know this is 8. We know this is 10. We know this is 4. We can now find this side, so be careful. That 8 does not go for the side here. It took me a second to look at it. That 8 is actually going to this whole thing. So it's telling me this whole thing was 8. So we actually don't know what this side is. Hopefully that makes sense. So we're going to ignore this 8 for now. That 8 goes here, not here. So we have to do the same thing. I don't know what that is. So a squared plus, I do know what this is, 4 squared equals, and I know my hypotenuse. So I know C is 10 squared. A squared plus 16 equals 100. Subtract 16 from both sides. A squared equals 484. Oh, there we go. Which is not 64, so don't tell me this is 8. I'm going to square root both sides. A is square root of 84. Now, like I said, you can double check to see if it simplifies. Square root of 84. And, oh, oops. Not square root of 84. 84 divided by x. 84 divided by x. Control T. And we're going to look for any perfect squares in here. 4 is a perfect square. Perfect. So 4 and 21. So square root of 4 times square root of 21. Now we could have also seen if there was a larger perfect square. 42, 3, 6, 14, 7, 12, 12, 7. Perhaps not, so we'll keep it here. And we'll say square root of 4 is 2. So this is going to become 2 square root of 21. Now 21 we can do 3 times 7. But 3 is not a perfect square, 7 is not a perfect square, and that's really the only way to get 21. So this is my simplified answer. But once again, that's not my answer. So I'm not done. I have to go back up here. And now this is 2 square root of 21. So my final answer for AC is 2 square root of 21 plus square root of 65. So AC is equal to 2 square root of 21 plus square root of 65. And I'll actually just leave my answer like this. Since I don't want to turn it into decimals and we don't really add. Oh, actually it's specified. To the nearest tenth of a centimeter. Never mind. Did not say leave in this simple irrational form, which means I do have to turn them into decimals. So 2 square root of 21. Let me look at my calculator, please. 2, oh, not calculator. 2 square root 1. Oh, plus square root of 65. We got 17.2. And I wanted it rounded to the nearest tenth. So 17.2. Right? Yeah, 17.2. So AC equals 17.2. That kind of covered it. There we go. Ta-da! Last question. That was a hard question. Way harder than the other examples. That's okay. We have a soybean field. One corner of the soybean field was not irrigated properly, so we can see that this was not irrigated properly. The dimensions of figures are in meters. How much money was lost by the farm of soybeans sold for $12 a bushel that year, and an acre of irrigated land yields 54 bushels. First, we need to figure out, okay, how many square meters are we talking about here? So, this is 170, and this is going to be my hypotenuse. So let's see. This is my A or B value, doesn't matter, it's one of my legs. So we can find the third side, so I don't know what this is. And by the way, the reason we want to find this is because we want to find square, where is it? Square meters. So we need to find area. But before we find area, it needs to be altitude times base. So I need to find my altitude, which I don't know. So I'm going to say I don't know A. So A squared plus 150 squared equals C squared. A squared plus, I actually don't know what 150 squared is, so, or actually, 22500, 150 squared, 22500, 22500 equal to, oh, let's not put C squared, we know what that is. Oh, that's not the eraser, this is the eraser. We know C is 170, so this should have been 170 squared. So 170 squared I don't have memorized. So let's actually put that one in. 170 squared 28900 28900 minus 22500 minus 22500 A squared equals minus 500 6400 square root to get A by itself. Is it 80? Square root for my answer. What's that? Yes, 80. So that's not my answer. So this is my A value. So now I'm going to redraw this here. So now what I'm going to do is I'm going to say, okay, well now I can do area is 1/2 base times pi, or one. Let's use the formula we've been using actually, which is the same thing, but we've been doing altitude times base divided by 2. So I'll just say base times height divided by 2. So area is that 80 times that 150 divided by 2. So 80 times 150 divided by 2. Divided by 2. 6,000. So my area is 6,000. So that tells me 6,000 square meters. Let me rewrite that so it's not going so up. And they tell me that soybeans sold for $12 a bushel that year, and an acre of irrigated land yields 54 bushels. 1 acre is 4,000 square meters. So I have 6,000 square meters, so I have some acres. So I'm going to say, okay, well, I'm going to take my 6,000, and then I'm going to say, hey, I'm going to multiply it by the unit conversion of 1 acre is 4,000 square meters. So I have meters squared here. So I'm going to do 6,000 divided by 4,000. 6,000 divided by 4,000, which is about 3/2, or 2.5, 1.5. So 3/2 acres. And then I know that within an acre, acre of land yields 54 bushels, so I'm going to say 3/2 acres times my unit conversion of 1 acre gives me 54 bushels. So I'm going to take this number and multiply it by 54. So I have 81 bushels. And then they tell me that they sold $12 a bushel. Or they sold for $12 a bushel. So then I'm going to take this 81 bushels and multiply it by the unit conversion of 1 bushel is worth $12. So times 12. So 972. So they actually lost $972. Yikes. Not the best scenario. Now this is your notes. Very, very long video, so you did watch it all through the end without doing 2 times speed or without skipping around. Very impressive. Work through your Delta Math. The Delta Math will have example problems, and they also have videos inside the Delta Math, so make sure to use those. I won't be here Friday, Monday, or Tuesday. So October 3rd, 7th, or 8th. So when I come back, hopefully I can answer any questions, but do try your best with this lesson. Hopefully it makes sense, and hopefully with your Delta Math, it'll make a little bit more sense with practice. But thanks for watching.